Okay, in this lesson, we're going to practice many of our exponent rules. And I've got them all mixed up. So again, these are our exponent rules. Hopefully you have viewed the video on exponent rules. And here we're going to practice exponent rules. Okay, in this first one, this is a chance for us to apply the very first rule where you are multiplying like bases. 3 and 3 are our base. They are like bases, they're on the baseline. So that means I can go ahead and add those exponents. So that would be equal to 3 to the 9th. Now I'm not going to write out 3 times 3 times 3 times 3, the whole thing. I wouldn't expect you to do that. What I'm wanting to move you toward is memorizing, applying those rules when you see them where they fit. Okay, here I have a base of some unknown number x to the 4th power times same unknown number x to the 6th power. We have like bases here, so we can go ahead and add those exponents. So this would be equal to x to the 10th. Okay, the next one, I've got p to the 4th times p to the 12th times p to the 8th times p. All like bases. They all have this unknown base of p. That's going to be equal to p to the, I'm going to go ahead and add my exponents, but I need to remember this implied here, p, is implied that it's to the 1st power. I've got at least one of them. So I'm going to have to include that. So when I add all that up, I would have p to the 25th. That's unusual that you would have something that big, but I'm just trying to get you to really think through these rules. Okay, this next one, this is x to the 1st power. I have to keep in mind that if there isn't a 1st power there, it's implied that it's there. So I need to include that when I'm carrying out the x to the, when I add these exponents, it would be x to the 4th power. And here I've got that situation where I have some known base here, 7 to the 0 power. That's going to be equal to 1, which is different. When I know my base, I've got a base of 6 to the 1st power. I've got at least one of those. So it's equal to 6. Just kind of making sure you're clear on that. Okay, so here I've got a product multiplying another product here. But keep in mind, I have like bases. So I can look at my base of a and look at those exponents. I've got exponents 2 and 7, so I can add those exponents. So that would be a to the 9th power. I'm not making my base look like an a. And then I've got a base of b to the 3rd power, b to the 5th power. I don't know if we want to put a different symbol around those, but we're going to add those, which would be b to the 8th power. Okay, so it got a little complex there just because we had two different bases there that we were dealing with, but we could simplify that. Okay, here is the first one where we're practicing where we are dividing like bases. We are going to go ahead and subtract the exponents. So that would be y to the 6 minus 2 would be to the 4th power. Same thing going on here. I've got like bases. I'm going to subtract those exponents. So it's going to be p 10 minus 1 is to the 9th power. Okay, here I have the difference or the quotient between two different products. But I can look at like bases. When I'm pairing up a to the 7th power divided by a to the 3rd power, that's going to simplify to a to the 4th power. I can do the same thing with like bases, the base of b. 6 minus 4 is going to be b to the 2nd power. Okay, and so here I have x cubed times this thing here. If you remember right, that is equal to 1. So I'm actually saying x cubed times 1, which is going to be x cubed. Nothing really strange there. Okay, here I've got a case of I'm raising a quotient to another power. So I'm going to have to apply that power of 2 to both numerator and denominator. So I can go x to, and this is the case where I am going to be multiplying. I'm raising a power to a power. I've got one exponential expression raised to another power. That's going to be x to the 12th. And then when I go ahead and raise the base of 5 squared, I could write 5 squared here, but I'm afraid you're going to lose track of, you know, my 5 squared could look like a 52, or if I really make it look like a 5 squared. But I can also, that's a small enough number that I can actually evaluate it. That 5 squared is 5 times 5, which would be equal to 25. So if it's a smaller number like that, you can go ahead and evaluate it. Okay, over here, we've got a different scenario, kind of a different scenario going on here, but I'm multiplying like bases. I've got a like base of 5, so I could look at that as 5 to the negative 2 plus 4. Remember, I'm collecting those exponents. So that comes up to be 5 squared. And if I wanted to, I could go ahead and evaluate it. It's small enough, I can evaluate it to be 25. It all depends on what you're expected to do on your, or what your options are in the HiSET exam. Here I have like bases, and I'm going to collect those exponents. So I'm going to have x to the, I'm sorry, because I wrote on there, you can't see my negative probably, but that's negative 3 collected with a negative 4, which is no big deal. That's going to be x to the negative 7. But remember, we also had a rule that when we have any base to a negative exponent, you could look at that as that negative exponent means the base is in the wrong place. I need to take that down to the denominator, so it'd be 1 over x to the 7th. You could write it either way. I just think you need to be able to recognize the same, that it could be written either way. Okay, here's a case where I have a base of 6, I'm sorry, base of 7, and I've got two different, I'm dividing this. So this would be 7 to the negative 2. If I'm dividing like bases, I'm subtracting the exponent. I need to be clear what I'm saying there. So negative 2 minus a negative 3. This is the first time I've had a negative exponent down here to deal with. But remember, I'm subtracting. I have to take the first one, subtract the second one. So when I do that, I've got two negatives side by side. So that's actually negative 2 plus 3, which comes out to be 7 to the first power. So that's just going to simplify it to 7 to the first power, or just 7 to the 1. You could write that in there or pass on that, whichever. Okay, this next one, I'm kind of applying the same rule. I've got b to the negative 2 minus an already negative 9. That's going to be b to the negative 2 plus 9, which means we've got b to the 7th power. Okay, so our negatives start to come and really mess with us because we're adding and subtracting, and we've got negatives here, there, and everywhere. So here we've got like bases, and we're subtracting the exponents again, so it'd be z. I'm going to put my z with a dash to it so you don't interpret it as a 2. But 5 to the 5th power minus an already negative 2. So now I've got z to the, these, I'm subtracting an already negative number, so that actually means 5 plus 2, which simplifies to z to the 7th power. So I'm just writing each of my steps down. You'd probably do some of that in your head. Okay, now here we're back to multiplying like bases. That means we're going to collect our exponents. So we've got m to the 10 plus a negative 10, which just means m 10 minus 10, which just means m to the 0 power, which is going to be equal to 1. Okay. Down here, we're kind of, what I want you to recognize is you have 3 different bases in here. The numbers on the baseline, whether they're a number or a variable, those are bases. You've got a base of 2, base number of x, base number of y. The x and the y have exponents. So this is like 2 to the 1st power. So I have to make sure that I apply this 4th power to all 3 of these exponents. In other words, 2 to the 4th power would be 2 times 2 times 2 times 2, which would be 16. Then I'm going to be looking at x to the 5th power times the 4 is going to be to the 20th. And then y to the negative 3, that's going to be negative 3 times 4, which is going to be y to the negative 12th. Now you could write that, and I would want you to write this as 16x to the 20th over y to the 12th, because that, probably off the picture here, because that power, that exponent is a negative, that means that needs to come down in the denominator. So, but you could write it either way. I just want you to make sure that you understand the meaning there. Okay, here's a case where I have 3 to the 4th power. That whole thing is raised to another 5th power. So what you need to recognize here is that this base, we could actually calculate it, but it's going to be huge. But I could multiply these exponents. So this would be 3 to the 20th power. And I'm sure at that point you'd probably go to the calculator and plug that in if you wanted to, but we could leave it as that right for now. Okay, here I have x to the negative 3 raised to the 4th power. I'm going to be multiplying those exponents. So that's going to be x to the negative 12. Negative 3 times 4 is to the negative 12. I could also rewrite this. That negative exponent means that the base is in the wrong place. It needs to go down to the denominator. So this is our base of x, needs to go down to the denominator, so x to the 12th. So that's equivalent to 1 over x to the 12th. Okay, and here we could apply this automatically to each term here, but I think it's probably easier to recognize that this negative exponent out here just means that this 4 should actually be up in the numerator, and this x cubed should actually be in the denominator, and then everything squared. So I would say let's apply that negative. So what I'm doing here is I'm applying that negative exponent, just the negative part of the exponent. So it just means I'm going to flip what's in my parentheses. So I'm going to write it 4 over x cubed, and that whole thing is going to be squared. I think that's the easier route to do here. So I can square both of these. So 4 squared would be 16, and then when I applied x cubed squared, I would end up multiplying those exponents, so that would be x to the 6th. And that's an awful lot to take in. On the high set, I truthfully am not sure that you would be doing anything of this level, but definitely simplifying, using any of these other rules could come in a variety of different ways.